Okay, so this is a magnetic field question from 2003 AP exam, AP Physics B. So I'm going to need space to solve this, but here's the general setup, some things I want to point out. So it's a railgun. So look, this sort of question here is, it pertains to major idea number one, where you have moving charged particles in a magnetic field. It tells us in the problem that we have a magnetic field. It says right here, the space between the thin frictionless rails contains a uniform magnetic field. So even though the magnetic field's not diagrammed on here, so see they're not showing magnetic field going in or magnetic field coming out. Do you know why they don't show it? Because if you look here, this question right here, they want you to figure out which direction must the magnetic field be directed. So we have a magnetic field between these rails, and this is major idea number one because you have moving charged particles in a magnetic field. This force right here, this force is the force of the magnetic field. Now typically when you're doing force of a magnetic field, the equation is QVB sine theta. Now, but if you have moving charged particles in the form of current, because remember, what is current? Current is simply charge per time, but would everybody agree that current is moving charged particles? Yeah. So the equation becomes this. Force of magnetic field becomes ILB sine theta, and it's not too difficult to derive this equation from that equation. Okay? So force of magnetic field is ILB. Now, let's revert this. Okay, so we're going to express all algebraic answers to the following in terms of F, where that's force of magnetic field, the constant magnetic force, other quantities given above, and fundamental constants. So, first question, determine the position X. Let me shrink this down so I got room to do this. So I got to finish this in about 5 minutes. I think I can do it. Wow. So, first question, determine the position X of the projectile as a function of time. So this really is an AP Physics 1 question. So notice they say the rails are, where does it say it? Right here, the rails are what? Frictionless. So if you sum the forces on this bar right here, which is free to move on the rails, what's the only force in the X direction? The force of the magnetic field. So you sum the forces, you get force at magnetic field. What is the sum of the forces always equal? MA. So therefore, the acceleration of the bar is going to be equal to F, which is the force over M. Now, what do they want? Determine the position. So now we go to a kinematic equation. X equals 1/2 AT squared. So they want this position as a function of time, so time has to be in there. So X, which is the position, is going to equal 1/2, take the A, plug it in, 1/2 F over M, T squared. So the position is going to be FT squared over 2M. That's the first question. That's the answer. Okay, second question. Determine the speed of the projectile as it leaves.
How is that a function of time?
Because T is in the equation.
Oh, my bad.
Okay, B. Determine the speed of the projectile as it leaves. So this is going to be another kinematic. I think the best kinematic here for question B, V final squared equals V initial squared plus 2AX. But what's the distance the bar is traveling? In the variable in the diagram. Are they using X? They're using L. So say 2AL, like that. Did I make a mistake?
Why don't you, no, I'm just asking, why don't you plug in FT squared over 2M for L?
FT.
Or is that because it's not the full distance?
Oh, well, this right here is the position as a function of time. But what they're saying is what's the velocity of the bar when it reaches the end of the rails, like this. So we don't know that this time right here is necessarily the end of the rail, right? But we do know that L corresponds to the end of the rail. So V initial is 0. So therefore V final, you're just going to go, it's going to equal square root 2AL. Plug in your A. A is F over M, so this is going to be 2 times F over M times L. And that simplifies to square root 2F L over, come on, pen, over M. Is that right? Yeah. Okay, C. Determine the energy supplied to the projectile by the railgun. Guys, what type of energy did this bar gain as it slid down the rails? Kinetic energy. Like if over here, what type of energy did the bar start with over here? Nothing. We have 0 joules of energy. It started from rest. As the bar slides down the rails, what type of energy is it going to have down here? Kinetic. So the gain of energy, it's just going to be kinetic. This is AP Physics 1 again. Kinetic energy equals 1/2 mv squared. We have the v right here, so plug that in. Plug in for v. So you're going to get kinetic energy equals 1/2 m, and then square root 2al squared. So this gives kinetic energy of 2. Wait, what is this? Al? Wait, we're not allowed to have. Oh, I messed up. This one. We plugged this one in. Sorry, I'm going too fast. This gets plugged in for v final. So plug that in right there. So this should be square root 2fl over m. 2fl over m, but then that's squared. So this is going to be, it just comes out to be, it actually simplifies just to f times l. Which, by the way, dude, what do you notice about this? F times L, that is what? That's the work equation. Remember, work goes into energy. The work done by the magnetic field equals the gain in energy of the bar. Okay, question D. In what direction must the magnetic field point in order to get this force? So this is right-hand rule number 1. So if you're given this question on the AP exam, you're going to say, according to right-hand rule number 1, so that's where your 4 fingers are the magnetic field, your thumb is the velocity of the charged particle, which way must the magnetic field be pointing? In order to get this force, the magnetic field must be pointing out of the page, right? It's like this. I mean, I can't show you if you're watching the video, I can't, but if you're right here, I can. It's going to be like this. In order to get the force, right, your thumb points up, right? The current points up. That's your thumb. Which way is the palm of your hand? To the left. So which way must the magnetic field be? Oh, sorry. I'm backwards. The force is to the right. Yeah, force is to the right. Your thumb is up. So which way are your 4 fingers pointing? Out. And then look, for this last question, you're actually going to calculate the speed. The thing is, though, L is the length of the rails. What you're going to plug in for the length of the bar is D. When you calculate this force right here, you're going to go I-L-D, where you make that 0.1 meters.